So beautiful, just like me. Ready, Jackie? So the thing you missed yesterday is that central angles come from the very center of a polygon, like that. So the number of central angles is the same as the number of sides. So this has 6 sides, it has 6 central angles, right? If it was regular, wait, Michelle, what's regular mean? Oh, you gotta know. Uh-oh. George, chance for redemption.
All the sides are the same in angles?
Yes, regular means it's all symmetrical. So all the sides are the same as the other sides, all the angles are the same as the other angles, right? So if it's regular, so let's say this is a hexagon, what would each interior angle be if it was regular? 60. Why?
Why did the equation work the same as?
Oh no, that's not why. What? All of these, you see, if I started here, went all the way around, they add up to 360 degrees. There are 6 of them. 360 divided by 6 is 60. It'd be 60 degrees. Well, we're going to do a pentagon. So what would one central angle of a regular pentagon be? What's that? 72. So 360 divided by 5?
Yes.
72. You guys agree? Okay. So one of the ways, there's lots of ways to construct different polygons, but we're gonna use the central angle to construct this polygon. Okay. So the first thing you got to do then, of course, is figure out, well, what's the measure of the central angle. So that's 360 divided by the number of sides, right? So central angle, let's see here, you could write this down too, right? Central angle for a regular polygon, that's just 360 divided by n. N being the number of sides, of course. Do you know what a shoelace's favorite question is? Do you know? Why not?
Oh.
I'm sorry, Monse. Forgive me. Okay. Now, put a dot. Nice and neat, somewhere in the middle of your paper. Got it? Okay. We're going to make a circle. Make a circle. Not too big, not too small. Goldilocks. Just beautiful and perfect.
In the middle?
Yep, right there in the middle of the page. It doesn't have to be. You don't have to make the circle real dark. It can be light. It's actually not part of the polygon, but because it's a regular polygon, we need all the vertices to be the same distance from the center. Okay?
Does it have to be bigger?
It doesn't really matter. Okay, now I'm going to use a pencil. Oh, somebody stole my pencil. They put it back. Good. So what we're going to do is we have to measure some 72-degree angles. And you have to be very accurate. If you measure accidentally 73 for one of them, then you're going to have 361 degrees. It's not going to be right. If you measure 71 degrees for one of them, you're going to have 359 degrees. So accuracy is really, really important, right, Bridget? So what I'm going to do is I'm going to make a little mark right here and another little mark all the way over here, right? So that the point lines up. You see what I did? See what I'm talking about? So I'm just going to connect that real easy. Just making it nice and light, doesn't have to be dark. I should probably go ahead and go all the way across. Now you got to really make sure you line up everything very, very accurately. So I'm putting my pencil on that line several places to make sure that it's lined up. And I have a little bit of a problem. I'm afraid that my line does not go exactly through my dot. That might cause a little issue. It looks pretty close on the camera, but when I look at it in person, it's a little tiny bit off. But we'll make it work. Right, Danny? Yeah. Okay, so let's measure 72 degrees. So really, really careful. 72 degrees. So let's see, 72 would be right. Oh, can you guys see that? 72 is right here. You see, because 110 and 70 would be, right? You follow me? So 70 and then 2 more after that. That's 72. Now without picking up my protractor, if I did another 72, that'd be 144, right? So I could just go all the way over here. 144 would be, that's 145, so that'd be 144 right there. Do you see how I got that? I measured 144 degrees. Yeah, so there's 72 right here, and then that's 144 from here. 144 degrees, that's 140 right there. So 4 more ticks after that would be 144. Do you see or not see? You sure? Okay. Now I can't do another 72 degrees because it would be off the edge, right? So actually, I kind of don't need this line right here, like this half. I'm going to erase it. Just like your future. Gone. Bye-bye. Would you rather your future be gone or your past? Wow, you guys are all over that. Alright. George, I need to measure another 72 degrees after this one. What do I need to do so I can do that? You think Adiam knows? Yeah, what do you think?
The same 0 line on...
Put another line right here, right, so you can measure it. Right. So you're gonna put a line right here so that you have something to measure from. Be very careful. Accuracy is important. So nice and light, doesn't have to be dark, and then I need to measure another 72 degrees. So 70's here. Sorry, 70's there, making sure you get everything lined up, and then 2 degrees. And then what? One of my measurements, one of my angles. A second angle. And then 144 would be right here. Let's see, trying to get it all on there. So Monse, the 72 degrees is right there. Looks like it's part of the letter F right there, but it's actually the mark right under the F. And then another 72 degrees. And then my protractor doesn't go it doesn't make a whole full 360. So I had to draw another line and line it back up. And then another 72 degrees right here. Oh, and I remembered because I was off by a degree, so I fixed it. And then another 72 degrees there. And then this should be 72 degrees from here to here. Yeah? Check this out. I don't need to draw a line from the center every time. But you see what I've got? Here's my first 72 degree mark to the center. What I do need is the intersection with the circle, because that will be the vertex. That's a vertex right there. Here's another vertex right here. I have 5 of them, right? So that's 1, 2, 3, and then here's 4, and So from there, you're going to connect those vertices together. There's one. There's two. Three. There's four. Last one. 5. Wow, that's fancy. That's a regular pentagon. Jesus, you doing good?
No.
No, why not?
I only have 2 lines.
Oh. So you don't have you have some not 72 degree angles on there then, don't you?
Oh, I do, but I haven't finished.
But what?
I haven't finished all the other lines.
Okay. You see I didn't draw all the other lines, Michelle? Because you don't need them. Right. What's your question, Sam? Nothing? You got it? Yes, Michelle.
If we did the lines, would that be wrong?
No, but you don't need them. And it's extra stuff on there. Yeah. Okay, let's talk about. Are you guys ready? No. Who is ready? I just want to see how you guys are doing. Oh, okay. That's pretty good. If you're ready, see if you can help somebody that's stuck that's near you. Jesus needs intervention over there, huh? So we're going to use imagination. So have a seat. We're gonna put some stuff on here, even if it's ugly. Even if it didn't work, we're just gonna drive forward. Whoa, that was a very clever way to get in the chair, Monse. Okay, I want to talk about some parts of polygons. Okay, so the first thing I want to label on here, I know you guys have it in your head right now. Oh, I hate my life. Okay, there we go. Sorry. So I know that you know what a central angle is right now, but let's go ahead and draw one on here and go ahead and label it. So this would be one of the central angles right here. Right? And label it outside like I did, and you'll see why in just a minute. Central angle. Right? And it's 72 degrees. All good? Now the next part I want you to know about, if you take one of the sides and you extend it, so I'm going to extend this side right here. Do you see how that creates an angle right here? This right here is called an exterior angle. George, how many exterior angles will a pentagon have? Who are we going to call on?
Kate.
Hi, Katie.
Hey.
How many exterior angles do you think a polygon will have?
5.
A pentagon will have 5, right? So it's the same as number of sides. There'll be n exterior angles. What do you think they add up to? What do you think, Danny? They do add up to 360 degrees, just like the central angles. They add up to 360 degrees. And if they're regular, you can figure out what each one is just by dividing 360 by n, right? Just like for the central angle. Okay. You guys see how the central angle makes a triangle? What kind of triangle is that? It is isosceles, because this side and this side will be the same, right? cool thing is about this, Felipe, is we can figure out what this angle equals and what this angle equals for any of them. Because it's going to be like 360 divided by n, right? So it's going to be 180 minus 360 divided by n. Whoa, wait, hold on. Okay, this is going to be really ugly. You ready? Oh, so would you agree that to figure out these two angles, like to figure out this angle right here, would you agree that it would be like this? It'd be 180 degrees minus the central angle divided by 2. Would you agree with that? Okay. And the central angle, would the central angle be 360 over n? That's really ugly. But I just wanted you to see where all the parts come from. That's not a formula you ever need to know, but that's what it happens. That's where it comes from. And I just wanted to show you that something like this might look really ugly and intimidating, but when you see what this means, it's no big deal. Alright, so what would this be? What do you think, Jackie? Felipe's got it, huh? What is it, Felipe? Do you guys agree with him? 54? 54 plus 54 is 108. 108 plus 72 is 180. Yeah, 54. Dang. Doing good? Yeah? Or no? Can I repeat that? Well, look, this is 72 degrees, right? They all add up to 180, right? 180 minus 72 is 108. And they're equal. 108 divided by 2, 54. Are we good, Bridget? Yeah. Okay, now, there's this part of a polygon that we don't actually use in Cambridge Math. But what it is if you took an angle bisector, if you bisected this angle right here, it would, because it's isosceles, if you bisected that angle, that would be a bisector of this side, right? This thing right here, this distance, I'm trying to figure out how to write this best. This distance right here is called the apothem. And that distance is used to find the area if you use the formula.
What is it called?
Apothem. A-P-O-T-H-E-M. Apothem.
Wait, I want to A-P-O-T-H-E-M.
So, alright.
Is the other one right too? The other one?
Well, yeah, because it has to be, because it's a straight line. Yep. So we have two right triangles. Nice thing about right triangles is you can find the area really easy, right? So you could find the area of this entire triangle, and then the area of the whole shape would be that times 5. Yeah, because there'd be one triangle here, another right here, another here, another here, and another here. So that's what we're going to do later. Yeah. Okay. Questions? You all good? Let's do, why don't you try? Let's see. Why don't you try? Let's see which one we're going to do. Let's see here. Yeah. Why don't you try an octagon? Make a regular octagon. You can turn your paper over. You can get another piece of paper. Try a regular octagon.